I'm here to talk about Microsoft and open source. I actually was talking to someone. I started working with Linux kind of late, 1997, right? So if you know the history of Linux, it started in 1994 roughly. But I share that because in that time, the open source community, you didn't do open source and take it to work and keep your job, right? That's not kind of one of the things that happened. So those communities historically were very separate, and so you had the open source folks doing their thing, and you had the proprietary folks doing their thing, and rarely the two met. And when they did, it was perhaps long after executives knew that maybe their mission critical workloads were actually running on open source. So what has happened in that time period? And I often look back over time. We talk about the cloud. Cloud, for me, my personal definition of cloud has always been separating the service from the hardware running the service. So if the hardware fails, you can move it around and the service is still available. And so in some ways, the cloud is not new, right? If you have VMware in your environment, you've got an on-prem cloud, right? If we think back to the late 90s, there were managed service providers who might run Office as a service. I remember this very clearly. And the limitation at the time was not the data center, but the connectivity to that data center. So as a customer, as a personal individual, I was not going to buy a T1 from my house to just run Office. It's very expensive to do that. So what has happened in the time period is we now have connectivity, high throughput, broadband everywhere, which actually allows for us to do these workloads in the cloud. And because of the innovation around open source in particular, you see this adoption at scale. So hopefully the slide works okay. What's happening at Microsoft? Part of the reason I came to Microsoft from Red Hat was this mission in particular, to empower every person in an organization on the planet to achieve more. Part of the open source framework is that the more minds you have participating, the better the solution can be for that point in time. So I love this mission statement, and in particular, I was told coming to Microsoft from Red Hat did not mean that I had to leave behind all of my experience in the open source community. Which, if you go back to like 2000, Linux and Microsoft just didn't happen. In fact, Microsoft called Linux a cancer. So that's a huge change in the way that Microsoft is viewing what's going on in the world. And the strategy is basically to provide an environment that's the best platform for humanity to do this workload, right? I do stress humanity because this is not just for businesses. This is not just for public sector or private sector or commercial or you name it. There are challenges that we have as a human species, and we're going to need computational resources to solve those challenges. And that's why Azure exists, and that's the focus for Microsoft as we move forward. Even with COVID-19, there's a ton of research happening in Azure, and much of it's kind of driven by Johns Hopkins, right? And they've partnered with Microsoft and Azure to do this research on providing current data around what's happening with COVID-19, right? Where the outbreak's happening and things like that. So these are things about how do we make the species better? How do we make the human species better? Not a thing that Microsoft would have done in the past. And so I keep stressing that because Microsoft has truly changed, and what this means for businesses and enterprises, whether they are public sector, private sector, commercial, governance, doesn't make a difference. Microsoft's approach is you bring what you need to Azure, and you don't have to necessarily change it either, right? You don't have to necessarily do it only on Windows. You don't have to do it with SQL Server. Those options do exist, but guess what? If you use MySQL, that's fine. If you use Linux, that's fine. Makes no difference to us at Microsoft. Our goal is to help you succeed in your endeavor. However you're doing that, we support that. So what you'll see on this slide, for instance, is the upper right-hand corner, 60% of the images in the marketplace are based off of Linux, right? Most of the innovation, if you go back to the early 2000s of what was going on in terms of software-defined networking and things like that, a lot of it was happening in the Linux community. And during my interview at Microsoft, I did not believe Microsoft. They were like, oh, this all runs on Linux. I didn't believe them. Turns out, a lot of the services that run inside of Azure are all based off of Linux, right? So Microsoft, and I think I heard Ron, you mentioned this earlier, right? Microsoft is eating the dog food. If we say we're doing something, we are doing what we're saying, right? And more importantly, we are learning through the process. We don't assume that we're going to know everything. We're open to learning, we're open to growing, and we're more importantly open to sharing that information back with the consumers of these technologies to improve your operations as well. So, so on the one hand, I go back a couple of years ago, I think it was 2014, maybe 2015, Microsoft and Red Hat came out with a joint support agreement and a joint offering around Red Hat Enterprise Linux and Azure and OpenShift and things like that. Unbeknownst, SQL Server now runs on Linux, right? So all these things were unthinkable, truly unthinkable 10 years ago, and now they're here. So that means for you as a customer, if you have SQL Server running on Windows, that's fine. You can run that in Azure too. If you want to run that on Linux, you can do that. However you choose to move forward, we support you in that endeavor. That's on the product side, the offering side, and the partnerships. We have partnerships with Red Hat, we have partnerships with Ubuntu, we have partnerships with SUSE, partnerships with SAP, Jenkins, all the community, because we really want to work together with everyone so that the success can happen. So if there are any questions, I'm not really looking at the chat window while I'm talking, I'm just making sure the slides work as advertised. So again, the approach that we have towards open source in the cloud is first, right, enablement, right? Give people the tools so that they can do this work inside of Azure. You don't have to leave behind how you've done your work in the past. That's not required. Take what you know, bring it into Azure. You can just start doing the work you've always done, and then once it's working the way it's worked in the past, then you can start looking at changing it, and specifically around the cloud. In this context, the global cloud is what I'm talking about. These services can scale globally, and a lot of customers that I work with in face-to-face meetings may feel like, I might be based out of Baltimore, Maryland. I'm not a global company, right? My customer base is just Maryland or whatever. The reality is, when you go online, the minute you have a service that's available on a public IP, you're working with the world, not just Baltimore. And so you might have customers in South Africa, and you don't want that traffic to come all the way back to the United States. Well, deploy that workload in Azure in South Africa, and then it can respond. The real point of all of this is to be able to respond to the incoming customer requirements or incoming requirements from whoever is using your service as quickly as possible, right? So the goal that we have at Microsoft is to put the data centers, that is the computational resources, the networking resources, data resources, as close to the end user as possible to keep latency low so that you can respond quickly to changing environments. And I think that, in my opinion, is the big change between life in 2020 and life in 1990 or life in 2000. Right? We couldn't respond as quickly to these environments. So the first part is to enable the workload. The second part is to integrate, right, with what you've been doing, or you might choose to re-architect that workload, right, so that it may move from a monolithic, all-in-one option to microservices. And you might do that so that if any one thing fails, it doesn't bring down the whole application. The whole goal is to make these services what you might call dial tone. And I think Russ talked about this earlier on in his talk with Sturgill, right? Downtime, you try and limit downtime, right? You want that service to be available whenever there's a need or request from a user for that service. And so now you have the ability to design these applications and these frameworks, and more importantly, since it's all based off of your data, and your data can now move across the globe, right? Your data can move wherever it needs to be timely for the consumption of an end user. So enable, integrate, release. Part of what we do here at Microsoft, we do our own development internally. We do releases on small scale, and then gradually, as we are confident that the services are going to work as advertised and not cause downtime for customers, we release those services to the rest of the globe. And then we also contribute back to the community, right? It's not just enough to consume. It's not just enough to create. Share back with others what you have done, because the goal, frankly, is continuous improvement for everyone in this process. So that's a very different model, proprietary workloads in the 90s and things like that, where your IP, your value may have been, I can do this service better than anyone else, and I don't want to share with anyone else because I'm going to lose business because of that. Those days are gone, right? Those days are truly gone. Your value now as an enterprise is your ability to service the needs of the people you're working with, the communities you're working with. So to that end, there's a lot of work that we at Microsoft do to make sure that our services are certified. Things like SOC 1, SOC 2, in the federal space especially, right, so that these workloads, if they're deployed, meet the federal standards. GDPR is another key area, such that that's sort of the standard then for how data is going to be treated within Azure, right? That GDPR standard, rather than just applied to Europe, GDPR applies to all the workloads inside of Azure. Right? So as an end user, your enterprise, when you're talking to your executives about doing something, you can say, you know what, wherever we deploy this workload, these conditions have been met, these standards are met, so we don't have to worry about that. We can move forward with developing the application and moving our data out there so that we can respond to the needs of the community or our customer base as quickly as possible. What does that mean? I talked about this before. If you use Linux, you're welcome. Linux is welcome inside of Azure, whether it's Red Hat. I used to work for Red Hat, so I'm partial to that. I'm not exclusive, but partial. So there's Ubuntu, there's SUSE, there's FreeBSD. You name the distribution, you can run inside of Linux. Can run inside of Azure, rather. So you can just bring your workloads over, or you can design something new based off what you want, but we're not forcing you to do it a certain way. That's the big takeaway, right, when it comes to Linux. So that's a huge difference, because historically that was not possible at Microsoft. The dev test out of the house, right? Because this is the real, this is where all of your real work happens, right? You're trying out something new, right? If you're refactoring out your application, you may choose to do these microservices and API deployments. You do them first in a small dev test environment. It can look and will probably look like your production environment, so that as you need to move from dev and test to production, you have less risk. When you flip the switch and go to production, it's going to work as you expect it to work. So all of this is designed for you to have spaces to explore, to try out something new with low risk, and then move that into production with a high sense of confidence that it will meet the business requirement that you've set forth. So. The other aspect, which I personally love, and I'm partial to this because I used to work in a research laboratory, an oceanographic research laboratory, where we used HPC, so high performance computing, to run, I shouldn't say we, the researchers used HPC to run single cell genomic workloads, so that in this use case, they wanted to figure out where phytoplankton was, where it was grown, and what was going on in that environment, so they could literally run a sequence against a single genome and tell you from that result this phytoplankton came from the Indian Ocean or the South Pacific, or you name it. And once you have all of that data, then you can actually put together this puzzle for how in this case, phytoplankton might be moving through the planet, around the planet, right? And you can start seeing patterns of movement. So you can then say, hey, this is what's going on here in the Indian Ocean, the South Pacific, in the Gulf of Maine, and then begin to predict, based off of that data set, what may happen in the future. We could not do that in the past, because we didn't, have the kind of resources that Azure provides at global scale. So when we were doing this work, we would send out researchers on a boat with a little data center that they do the work and process it local. But it was very costly and, more importantly, difficult to combine the data sets of 20 researchers and to keep that data around for a long period of time so those researchers could reformat or reconsider their calculations and their ideas and reprocess that data. So the Planet does some of this with Ice Force and Planet and things like that. You can now do that in Azure, right? You can put this data up in Azure. What you have today can stay there 5, 10, 20 years, so that if you need to run analytics over what happened in the past, you can do it as a predictor for what's going to happen in the future, what may happen in the future. So these are some of the amazing, in my opinion, developments that now exist so that as a business or an enterprise or whatever your organization is doing, this data, this historical data, you can use to help inform your decisions as you move forward in making those business decisions. Are there any questions? Because I know I'm moving through this very quickly. I don't even have a watch out. So Ron, let me know how I'm doing on time, because I want to be sensitive to the people after me as well.
I think we're doing fine. We've got another 10, 15 minutes. I think it's going well. And I would just also comment, just check to make sure there's a little echo, not so bad, but just make sure that the volume is turned down appropriately in your office so everyone can hear you even more clearly.
Beautiful. Thank you for that feedback. My brother is a sound engineer, and he hates when I call him because he says there's too much echo in my space. So thank you. I'll turn down the volume as well. So that's on the high-performance computing side for people who are doing work with application development, right? All these Java applications that have been around since the late 90s, early 2000s, right? Those can now run inside of Azure as well. Again, the takeaway is bring whatever you want, whatever tool set you want to use inside of Azure, and not so much the tool set, but whatever your staff, the humans in your space may know, that can work just fine inside of Azure. So if that's JBoss from Red Hat, if it's WebLogic from Oracle, all of these are welcome. They all work. What does that do for you as an enterprise? That frees you up from having to worry about what is possible as you move forward. There's a huge amount of energy that gets released when people don't have to worry about what they cannot do, and they can focus on what they can do. And that is the real value that I see happening with Microsoft and Azure now. If you are a development shop, an application development shop, all of that is welcome inside of Azure as well. For folks, and I've been using LAMP stacks for the last 20 years. I'm on the more infrastructure side of the house. I refer to that as the kitchen, right? Those are the people who build the kitchen, people that write code are the chefs. They actually use the kitchen to make things that people really want, right? Applications, beautiful tools, and things like that. So all of that is supported in Azure, right? Whether that's, we already know that Linux is there, Apache is there, MySQL is supported, Postgres PHP is supported. If you're on the application side, that's MongoDB, Angular. All of these frameworks can be used in Azure. So it's not like you have to, I keep coming back to this, you don't have to keep leaving what you know behind. You can leverage what you know as you move forward. And then if you want to learn something new, guess what? That option is available as well. So that gives you the ability to respond quickly to the changing environments. And that's more than anything else. Ron, I think you may have mentioned how Satya Nadella said early on that there was like 10 years of development that happened right in 2 months because of the pandemic, right? This is a very different time in human history where I work with several large enterprises who actually had great difficulty justifying transforming their business digitally pre-COVID-19 because they didn't want to disrupt how their business was working, and they didn't actually have the staff to really look at forward thinking. And when the pandemic arrived, it caused really a stop for lots of places and gave companies the time, since we're all at home we're all at home sheltering in place in many cases. Business sort of stopped. It gave these enterprises the time to start planning to do some things new in ways they would not have been able to do in the past. And so what they came back to us and told us was Azure, and not just a subset of what goes on in Azure, but the entire portfolio, and that goes from infrastructure through to software as a service, if you're using things like Cosmos DB, or even platform as a service, things like OpenShift, or the container services that exist inside of Azure. All of those meant they could now reconsider how they're going to do business for the future, because the conditions of the world were creating that possibility for them, where they couldn't have done it in the past. So I share that because there's a lot of possibility here, and the limitation is really around how we choose to think, not necessarily technical any longer. So we move on. And I shared some of this earlier, but the traditional model around data centers is really, an application per server. And there was good reasons for that if you go back historically. The reason is you want to maintain uptime on that service, right? And so you dedicate a service to a piece of hardware. Whether that service is used a lot or not doesn't matter, but you know that if someone wants to use it, it's going to have high uptime. That's the intent behind all of those things. And also, again, going back to connectivity, we didn't have lots of high broadband across the planet in the 90s. 56K modems, maybe some ISD inline if you're lucky at home. Businesses had T1s and T3s and things like that, but consumers didn't have, and we surely did not have cell phones, right? We didn't have these amazing computers in our pockets that run all the things that we couldn't do back in the 90s. So the traditional model was appropriate for the time, but moving forward, the cloud model is you design loosely coupled applications, lots of microservices if you can, so that they can fire up when needed and turn down when they're not needed. And they can talk to the data that's waiting for them in the back end, because the data may be replicated from North America to Europe, or from Europe to South Asia, or from Asia to South America, right? Wherever I as the consumer might be using that data, it's already there waiting for me. And then you're looking at non-proprietary hardware, but industry standard hardware across the board. And you're focused on, I think it was Aaron from Trend Micro before, who was talking about security in particular being part of the process from the beginning, right? Many places historically, and also because of the cost computationally, viewed security not as a requirement. And also, if you're just doing stuff inside of your own perimeter, you may not have been, your trust may have been implicit for the people in your organization, right? One of the things that the federal, U.S. federal security groups talk about in terms of breaches, most of that comes from internal, not external, right? 90% of the breaches are internal, not external. So that's why Microsoft moves towards a zero trust model, which is explicitly secure everything, least privilege across the board, guarantee that people don't see what they don't need to see, and if they need to see it, they have to have explicit permission to do so. Standardize your processes and procedures across the board. You do that from the beginning. You do automation and configuration management from the get-go, not as an afterthought. So those are some of the better practices as we move forward. And there are going to be enterprises that are going to be straddling both of these, right? There are places that have workloads that were done in the early 2000s where they actually didn't have sort of practices in place, but their businesses depend on those workloads for revenue. So they're going through this process of modernizing, refactoring that are more secure, more agile, more scalable. And that's a learning curve. Most of that actually is cultural inside the organization with people, less about technology. So that's a brief overview of the cloud models to move forward. I don't see that actually changing over time. That's going to become the norm. So my kids are doing software right now. They start out with microservices, right? They don't even think monolithic because that's not the world they grew up in. Good Lord, yeah. So there's a whole change coming. And are we flexible enough to grow and learn in that process, right? So, Ron, are there any questions that you see in the chat by any chance? There may not be, and I just don't want to miss any if there are. So.
Well, fortunately, your colleague Jay was communicating with Elizabeth all about the importance of Microsoft's proprietary fiber network. And just to share with everyone, Microsoft has this huge backbone literally across the globe. So if people have concerns about latency, performance, security, that's part of the reason why Microsoft has made this huge investment in so much fiber running on the ocean floors and across all the continents.
Absolutely, and thank you, Jay, for answering that question. I appreciate it. I will also go another step further, that in addition to that fiber backbone that we have that's global, Microsoft is actually deploying data centers in the ocean. So the idea is to put these data centers just offshore so that, let's say in South Africa, for instance, there's not one there yet, but it possibly could happen, right? Instead of that data having to go back across a huge continent, right? If it just has to go a couple of kilometers off the ocean floor, then that means the response time, the ability to respond to local markets, local changes is much faster. And I think that's really where things are going. I didn't want to geek out too much, but when we talk about the way Azure data centers are designed, and there's a term in the industry, and many folks on the call may know about it already, it's called power usage efficiency, and it's a metric that describes the amount of energy coming into a data center and the amount of energy that gets actually allocated to compute workloads. There's some laws related to cooling and things like that. Historically, on some on-prem data centers, you might have PUE of 4, right? 4 watts into 1 watt to compute. That's a significant amount of loss, right? So the goal is to get that PUE number down as close as possible, 1 to 1. I'm not sure if it's ever going to be possible that there's no loss, but Microsoft's data centers in Azure, they're close to 1.10, right? It's getting very close to all the energy coming in goes to compute. There's no loss. What does that mean for a company? That means if you're building out a budget for a project and you're going back to the business can say, you know what, I have $10,000. You can safely say $10,000 is going to go to compute, right? They're not going to be paying for lots of overhead to get their work done. So that's the goal behind all of this, is to make sure that the overhead to get a workload done is as low as possible, so that the money that we're spending, the resources that we're spending to get this work done, as much of it is going to get the work done as possible. So we get the best answer for what we're committing to that. Right. So that's a phenomenal place to be in, because historically the PUE numbers were quite high, which meant you might spend $2 to get $1 worth of work somewhere, right? And that means you're budgeting double, triple what it costs to get the work done, and that's not good for business, right? So if you get that number back down closer to 1, that means you get more for your dollar, or whatever the currency you're spending, right? You're getting as much possible from that workload. So that's work that Microsoft Research is doing around Azure and operational efficiency, improving that over time, so that as a consumer or a user of this service, you're just paying for exactly what you're using. You're not paying for any more than that, which is a beautiful place to be in, right?
Hey, James?
Yes.
I just want to make a couple of comments, and then as I'm making these, maybe you could start preparing your summary comments. The thing that I see a lot of is that as we go to the cloud, the speed of light actually matters. And when you've got major financial trading firms wanting to get insights into so much data instantaneously, milliseconds or nanoseconds matters. That's why Microsoft's strategy of maintaining its own fiber and putting data centers closer to end users matters. So if you're literally on the other side of the world, you don't want to wait a couple of seconds for your data to transmit around the equator. So it does matter, and that's very relevant. The other thing that I want to point out is that as you're looking at when to go to the cloud, regardless of open source, proprietary software, Kubernetes, microservices, cloud native design, one of the things that I want to point out is that Microsoft can run its data centers more cost effectively as far as power cost than pretty much anyone else. And Microsoft can also buy servers and hardware cheaper than just about anyone else, aside from another big company in Seattle or another big search company in San Francisco. I guarantee you they can buy hardware cheaper. And then you get the economies of scales effect, which is the more that Microsoft can do in the cloud through its internal customers, through LinkedIn, through Office 365, through Bing, through Dynamics, and the more external customers they line up, the cheaper their services can be. So one of the opening questions came, how aggressively should I look at moving on-prem to the cloud? My recommendation is it depends on your situation, but you really want to embrace it because Microsoft power costs are less. Get rid of all those overhead costs of running power to your own on-site data center with all the backup you need, all the electricity you can consume, all the overhead in managing that. And that's why we hope that everyone will take a more aggressive approach, regardless of COVID-19, because it will save you CapEx, and it may actually save you operating expenses as well. Anyhow, let me turn it to you, James, because we want to queue up Tonio to talk about Synapse.
Right, I would absolutely agree with what you're saying. I always encourage folks to take a posture of learning and embrace that. Number one, the only reason that I would say that you might keep something on-prem is because there may be some sort of legal reason, or your company may not. In many cases, a board may not feel comfortable putting their data right somewhere else. So there may be some business requirements to keep something on-prem, but if the business is comfortable and willing to explore these options, then it is exactly what Ron said, right? You can begin to create an environment where your CapEx and OpEx are lower, and your ability to transform into an organization that can respond faster to the changing environments around you increases, which means you will be viewed as a valuable partner in a community, right? That's the purpose of all of this, so that we can help. I have high aspirations, but we're trying to help everyone improve over time, right? And the faster we can do that, the better we are, right?